Hey there guys, welcome to my walkthrough of the June 2017 Edexcel Higher GCSE Maths Paper 2, which is a calculator paper, so make sure you're armed with your calculator. Now I will say, this paper is pretty hard, so be warned, but that does mean it's really good practice for your exams. There will be lots of useful stuff linked down below in the description, including my playlist with every Edexcel Higher GCSE 9 to 1 Maths paper walkthrough. So, make sure you check out the description, and let's go. Okay, question 1, probability. So, the table shows the probabilities that a biased dice lands on 2 or 3 or 4 or 5 or 6. Not 1 though. Neymar rolls the dice 200 times. We want to work out an estimate for the number of times the dice will land on 1 or 3. So, to do that, we would add the probabilities of 1 and 3 together. That would give us the total probability for getting a 1 or a 3, and then we multiply that by the number of times we roll the dice. Think about it. If you flipped a coin 10 times, we know the probability of a head is 0.5. So we would expect to get a head half of the time, so 5 out of 10 times. So you always do the probability of an event multiplied by the number of times you are doing whatever it is we are doing. So here, rolling the dice. So we need to first of all work out the probability of getting a 1. Now, probability always adds up to 1, so if we find the probability of not 1, so we add together the probabilities for 2, 3, 4, 5 and 6, so make sure for that you get 0.69. Now the probability of getting a 1 then is 1 minus 0.69. Which is 0.31. So now we know the probability of getting a 1, we can work out the probability of getting a 1 or 3. So for that, we add the probabilities together. So 0.31 and 0.18. And that gives us 0.49. So now we know that probability, we just do 0.49 times 200. And that gives us 98. Okay, number 2, on to a 5 marker already. So, on Saturday, some adults and some children were in a theatre. The ratio of adults to children is 5 to 2. So, straight away, I'm going to write that down. So, cool. So what that means is, for every 5 adults in the theatre, there are 2 children. We are told each person had a seat in the circle or in the stalls. 3/4 of the children had seats in the stalls. 117 children had seats in the circle. So up to that, we now know that 1/4 of the children were sat in the circle. So 1/4 of the children is 117. So from that, we are going to be able to work out the total number of children. We're told there are exactly 2,600 seats in the theatre. On this Saturday, were there people on more than 60% of the seats? We must show how we get our answer. Okay, so I think the first thing that I would do is get the target number of seats. So work out what 60% of 2,600 is. So 60% of 2,600. Now on a calculator paper, you do not want to be faffing around finding 10% and doing it like that. 60% is 0.6, so multiply 2,600 by 0.6. Now that gives us 1,560. So that's our target number of seats. Okay. So what we need to do then is we need to work out the total number of children and adults in the theatre. Now, we can find the total number of children because we know 3/4 of them were in the stalls, so that means 1/4 of them are in the circle. So we can say, if we call children C, makes sense, we know then that C over 4 is 117. So if we multiply through by 4, the number of children is 4 times 117, which is 468. So we now know the total number of children. So there are now a couple ways we can think about using the ratio to find the number of adults. So the way that I'm going to think about it is, altogether the ratio has 7 equal parts. 5 parts are the adults, 2 parts are the children. So the ratio has 7 equal parts. Now we know that, again, the children make up 2 parts, and we know there are 468 children. So, 2 parts is 468. So, from that, we can work out that 1 part is 234. Now, at this point, we could work out how many adults are there and add it to the total number of children, or we could just work out the total number of people. We now know that this is one part of the ratio. The ratio altogether has 7 of these parts. So the total number of people is 7 times 234. Now that is going to give us 1,638. Now that is greater than 1,560. So the answer is yes. More than 60% of the seats were filled. Okay, number 3, bit of drawing. So the diagram shows a prism with a cross-section in the shape of a trapezium. On the centimetre square grid below, make a scale drawing of the front elevation and side elevation. Use a scale of 2 centimetres to 1 metre. Okay, so let's go through the lengths of the shape and turn them into centimetres. So if 1 metre is 2 centimetres, 2 metres is 4 centimetres. Okay, and then the base is the same. And then we got 0.5 metres on the right. So if 1 metre is 2 centimetres, half a metre is 1 centimetre. Okay, so our front elevation should look like that. We could label it. Okay, so it's 4 high, 4 wide, and 1 high on the right. We didn't need to worry about converting in the diagonal because the other 3 lengths take care of the diagonal. Okay, then for the side, so again, we got, first of all, we got this rectangle at the bottom. Now 1 metre is 2 centimetres, 0.5 metres is 1 centimetre. So the first bit we need is a 2 by 1 rectangle, which is where this guy comes from. So we need the top of this rectangle because that's going to be the lip. And then we're going to see the slope going back. Now we know that slope goes up another 3 metres, which is another, not 3 metres, 1.5 metres, which we know is another 3 centimetres. So the side will look like this. Cool. Okay, number 4, we have some speed, distance, time fun. So, Ollie drives 56 kilometres from Liverpool to Manchester. He then drives 61 kilometres from Manchester to Sheffield. Ollie's average speed from Liverpool to Manchester was 70 kilometers per hour. Ollie took 75 minutes to drive from Manchester to Sheffield. Part A wants us to work out Ollie's average speed for his total drive from Liverpool to Sheffield. Okay, so average speed overall well, remember, speed is distance over time, so it's the total distance divided by total time. Okay, so the total distance we can work out no props. So the total distance well, that's the 56 and the 61, so that gives us 117 kilometers. Now for the total time, we need to work out the time that he took to get from Liverpool to Manchester. So, remember that speed is distance over time. Hopefully you've seen formula triangles before. So we got S dt now in these guys, to cover up what you want, so here we want time, it leaves you with the formula. So time is distance divided by speed. So for Liverpool to Manchester, his time was 56 divided by 70. Now that gives us 0.8 hours. Okay, so now that we know that, we now also need to work out what 75 minutes was in terms of hours. So 75 minutes well, that's 1 whole hour, 60 minutes, add 15 minutes, which is a quarter of an hour. So 75 minutes is 1.25 of an hour. So here's total time. Is 1.25 hours add 0.8 hours, which gives us 2.05 hours. So finally, his average speed is 117 divided by 2.05. See what that gives us. So that gives us 57.07, blah blah blah. So let's go to one decimal. That's 57.1 kilometers per hour. Cool. Okay then, part B. Janie drove from Barnsley to York. Janie's average speed from Barnsley to Leeds was 80 kilometers per hour, and her average speed from Leeds to York was 60 kilometers per hour. Janie says that her average speed from Barnsley to York can be found by working out the mean of 80 and 60 kilometers per hour. Part B. If Janie is correct, what does this tell you about the two parts of Janie's journey? Okay, so quite a tricky one probably to wrap your head around. Imagine that you were in a ridiculously fast car and you travelled 100 kilometers per hour for 10 hours. And then you slowed right down and you went 30 kilometers per hour for 1 hour. The fact that you have gone at 100 kilometers an hour for 10 hours and then only 1 hour at 30 kilometers per hour means that the part of your journey where you were going at 100 kilometers per hour far outweighs the part of your journey where you were only going at 30 kilometers per hour because you were only doing that for 1 hour. To be able to work out an average speed by just adding the two different speeds together, you must spend the same time with each average speed. So if Janie is correct, the two parts of her journey must have taken her exactly the same time. Okay, number 5, we have some similar triangle fun. So ABC and EDC are straight lines. EA is parallel to DB. So those are the two lines with the arrows on. Those are what tell us these two are similar triangles. So we're told EC is 8.1 centimeters, DC is 5.4, and DB is 2.6. So at that point, what I would do, and what I have done, is make two sketches of these triangles. So here they are down here. So I've got the big one and the little one. So the big one is AEC. And the lengths of that one that we know are EC is 8.1, And that's all we know on the big one. Okay. And then the little triangle is BDC. Now on this guy, we know that DC is 5.4. And BD is 2.6. Okay, so part A wants us to work out the length of AE. So we want this length here. So when two triangles or shapes in general are similar, it means that the lengths are connected by a scale factor. Now to find the scale factor, you do the length of the big shape divided by the corresponding length of the small one. So our scale factor here, so the only way that we can do it is by doing 8.1 divided by 5.4. Now that gives us 1.5. So we want AE. Now we have the corresponding length on the small triangle, which is BD. So to get from the length of the small triangle to the length of the big one, we multiply by the scale factor. So AE is 1.5 times 2.6 centimeters. And that gives us 3.9. Cool. Okay, then part B tells us that AC is 6.15 centimeters. So that's this length here. And we are asked to work out the length AB. Okay, so if we go back to the original diagram, what we want is this length here. So AB is AC minus BC. So we need to find BC. So to get from the length of the big triangle to the length of the small triangle, we divide by the scale factor. So BC is 6.15 divided by 1.5, and that gives us 4.1. So, do it back up here. We know then that AB is 6.15 minus 4.1 centimeters. And that gives us 2.05. Cool. Okay, number 6, we have compound interest, so my percentage increase and decrease playlist is down below. So, Neil wants to invest £25,000 for 3 years in a bank. Right, personal bank, he gets paid compound interest at 2% for each year, or at secure bank, he gets compound interest at 4.3% for the first year and 0.9% for each extra year. We are asked which bank will give Neil the most interest. At the end of 3 years, you must show your working. Okay, so essentially then we just need to work out how much he's going to have in each account after 3 years. So let's do personal bank first of all. So for personal bank, so I'm going to think of this in terms of decimal multipliers, which really is how you want to be doing this. So 2% is 0.02. So to work out how much money Neil is going to have after 3 years, we do 25,000 times 1.02. That would work us out how much is in there after 1 year, but we want 3 years. So we work a power of 3 on the multiplier. Now that gives us £26,530, 20p. Okay, and then for secure bank, .3% is 0.043. Zero point 9% is 0.009. Now you could work out first of all how much he's going to have after that first year. So to do that, he would do 25,000 times 1.043. So you could work that out. You don't need to though. What we can do is also then multiply by 1.009 squared. and that is going to give 26,546 pounds 46p. So that's more than the other place, so he should use secure bank. Cool. Okay, number 7. So this is the final question that was also on the foundation paper, so the real fun is about to start. So a number n is rounded to 2 decimal places, and the result is 4.76. Using inequalities, write down the error interval for n. So I'll put my videos on error intervals down below. Basically, we want the smallest number that would round up to 4.76 to 2 decimals, and the smallest number that would not round down to 4.76 to 2 decimals. So it's a double inequality with n in the middle. Now the lower bound is an or equal to inequality. And you always need one more decimal place than we've rounded to. So this is going to be 4.755. And then for the upper bound, you use a strict inequality. And the first number that doesn't round down to 4.76. So that's going to be 4.765. That would round up to 4.77, and that is why we use a strict inequality on the upper bound. Cool. Okay, number 8, cumulative frequency. So the cumulative frequency graph shows some information about the heights of 60 students. So we have cumulative frequency up the side and the heights along the bottom. We are asked to work out an estimate for the number of these students with a height greater than 160 centimeters. Okay, so what we need to do is find 160 along the bottom, which is here. Go up until we hit the curve. So you can, if you want, draw a line up to the curve. Now we hit it there. So anyone to the left of this has a height less than 160. Anyone to the right has a height greater. So we want the people that are on this part of the graph. So we now go across to get our y value. So we are here. Now the scale is nice. Every little square is 1. So we've come across to 48. So we want the people above that. So we just do 60. minus 48. And we get 12. Cool. Okay, number 9, we have some transformation fun. So, Kyle reflects triangle A in the x-axis to get triangle B. He then reflects triangle B in the line y equals x to get triangle C. Amy reflects triangle A in the line y equals x to get triangle D. She then reflects triangle D in the x-axis to get triangle E. Amy says that triangle E should be in the same position as triangle C. Is Amy correct? You must show how you get your answer. Okay, so I've done it by carrying out all of the transformations. So the line y equals x, hopefully you're happy with that. It goes through 0, 0, 1, 1, 2, 2, etc. So let's do Kyle's first of all. So he started off with triangle A. He's then reflected it in the x-axis. So that ends up down there. And he's then reflected B in the line y equals x. So if you're not sure how to do these, pick a point. So let's go with the tip of the triangle. And then count how many squares we can go diagonally to get to the line. So 1, 2, 2.5, so we go the same distance on the other side. So there's the half, 1.5, 2.5. So do that with all the points and you will get triangle C there in the top left. Okay, then Amy started with triangle A and reflected it in the line y equals x. That gave us triangle D. She then reflected that in the x-axis and gave us triangle E down there. So we can see that E and C are not the same. Is Amy correct? No. Okay, number 10, we have standard form. So the table shows information about 8 planets. So we have the distance from Earth in kilometers and mass in kilograms. Part A wants us to write down the name of the planet with the greatest mass. So ideally there would be one planet with the highest power of 10, which there is Jupiter 1.898 times 10 to the 27. So the answer to part A is Jupiter. Part B wants us to find the difference between the mass of Venus and the mass of Mercury. So, difference means a subtraction. So the mass of Venus is 4.869 times 10 to the 24. So we're doing 4.869 times 10 to the 24 minus the mass of Mercury, which is 3.302 times 10 to the 23. Work that in your calculator and you will get 4.5388 times 10 to the 24. Cool. Okay, then for part C, Nishat, great name, says that Neptune is over 100 times further away from Earth than Venus. Is Nishat correct? You must show how you get your answer. So, how do we work out how much or how many times further away Neptune is than Venus? We divide. So we need the distance for Neptune, which is 4.35 times 10 to the 9. Divided by the distance for Venus, 4.14 times 10 to the 7. And that gives us approximately 105. So Neptune, it's just over 105, it is over 100 times further away from Earth than Venus. Is Nishat correct? Yes. Cool. Okay, number 11, one says to solve 3x minus 2 over 4 minus 2x add 5 over 3 is equal to 1 minus x over 6. Okay, so there's quite a few different approaches we could take. The method that I'm going to use is, first of all, making all of the denominators equal. So, the first number that 4, 3 and 6 go into is 12. So I'm going to turn each of the bottoms into 12. So to turn 4 into 12 we multiply by 3. So whatever we do to the bottom we have to do to the top 2. So we are going to get 9x minus 6 over 12 minus, now this minus affects both terms on top of the fraction, so I'm going to put the top into brackets. Now to turn 3 into 12 we multiply by 4, so on top we get 8x add 20. And then on the right, multiply the top and bottom by 2. So 2 minus 2x over 12. Okay, so fractions are divisions, so everything here is being divided by 12. We can cancel that out by multiplying 3 by 12. So we then get 9x minus 6 minus. Now then, if we also expand the bracket, we get minus 8x minus 20 is equal to 2 minus 2x. Okay, now if we simplify the left hand side, 9x minus 8x is just 1x. Minus 6 minus 20 is minus 26. And on the right, there we go, 2 minus 2x. Okay, now if we add 2x to both sides, we get 3x minus 26 is equal to 2. Add 26, 3x is equal to 28. Divide by 3x is 28 thirds. Cool. Okay, number 12, more probability. So there are 30 students in Mr. Lear's class. 16 of the students are boys. 2 students from the class are chosen at random. Mr. Lear draws this probability tree diagram for this info. Okay, so there's this tree diagram. Part A says, write down one thing that is wrong with probabilities in the probability tree diagram. Okay, so let's look at the first one. So we got boys, 16 out of 30, girls, 14 out of 30, that's cool. So the probabilities are right for his first selection. For the second though, if he's already chosen one person, there's one less person to choose from. So these probabilities are wrong. So they should be out of 29, not out of 30. So that is the one thing wrong. Okay, and then for part B, Owen and Wasim, maybe, play for the school football team. Probability that Owen will score a goal in the next match is 0.4. The probability that Wasim will score a goal in the next match is 0.25. Mr. Slater says the probability that both boys will score a goal in the next match is 0.4 add 0.25. Is Mr. Slater right? Give a reason for your answer. So, is not right. Imagine if you flip a coin and roll a dice. Imagine then putting those on a tree diagram. So let's say heads from the coin and 1 on the dice. So the probabilities for the coin would be a half and a half. The probability of getting a 1 on the dice would be 1/6. You don't add the probabilities, you multiply them together. So Mr. Slater should do 0.4 times 0.25 to work out the probability for them both scoring a goal. As it goes, that would be 0.1. Cool. Okay, number 13, we have fun with a histogram, so my histogram stuff will be down below. So this histogram shows some information about the ages of the 134 members of a sports club. Okay, so we have frequency density going up the side and the ages going along the bottom. We are told 20% of the members of the sport club who are over 50 years of age are female. We want to work out an estimate for the number of female members who are over 50 years of age. Okay, so the important thing with histograms is that the area of the bar represents the frequency in that interval. So what we need to do is work out an estimate for the number of members over 50 and then find 20% of that. So let's find 50 along the bottom. So it's going to be there, slap bang in the middle of 40 and 60. So we want the area of the bars to the right of that blue cross. So probably not going to go very well, but let's try drawing a line. Okay, so the width here is 10. Now we need the frequency density, which is the height of the rectangle. So we can see one big square represents 0.5, which means every little square represents 0.05. So this frequency density is two little squares below 1.5, so it's 1.4. So now this part is the reason it's an estimate. Just because we're cutting the bar in half doesn't mean half the people between 40 and 60 are over 50. So it's an estimate. So the area for this bit then is 10 times 1.4. Which is 14. So now we need the area of the last bar. So the interval goes from 60 to 90. So the interval width is 30. And the frequency density is 4 little squares above 0.5, so that's going to be 0.7. Now 30 times 0.7 is 21. So the estimated members over 50 is 35. 20% of those we are saying are females. So 20% of 35 is 7. Okay, number 14, we are given some graphs and we are asked, in the table below, match each equation with the letter of its graph. So, first up, we have y is equal to sine of x. So it's one of our trig graphs. We should be familiar with it. It's going to be this guy. So sine of x is 0 when x is equal to 0 and 180. It's 1 when x is equal to 90. And it carries on like that forever and ever and ever, both ways. So the first one is C. Okay, then the next one, y is x cubed, add 4x. So, cubic graphs look either like that, or something like that. So, our guy here is going to be f. Okay, then we have y is 2 to the power of x. So this is an exponential graph, and these guys look something like that. And they always cross the y-axis at 1. Okay, so that is going to be graph A. Okay, and then the last one, y is 4 over x. So this is inverse proportion. As x gets bigger, y gets smaller, and as x gets smaller, y gets bigger. So, in the positive part of the graph, x gets bigger as you go off to the right, and x gets smaller as we come back towards the y-axis. So, inverse proportion looks like that. Now it also does the same down in the negative part of the graph, like that. So, our guy here is where's he hiding? There he is, graph H. Cool. Okay, number 15, we have circle theorems and similar triangles. So, A, B, C, and D are 4 points on the circumference of a circle. We are told A, E, C and B, E, D are straight lines. So, those are the lines going diagonally through the circle. We want to prove that triangle ABE and DCE are similar. Now you must give reasons for each stage of your working. Okay, so triangle ABE is the top guy. So this chap and triangle DCE is this bottom chap. Okay, so I'm not gonna do any of the writing just to keep the length of the video down, but I will walk you through it. So, triangles are similar if they have 3 pairs of equal angles. All that they really need is 2 pairs of equal angles, because then the third pair has to be equal too. So, first off, this shape here is a circle theorem. So, we call this angles in the same segment. Now, by this circle theorem, this angle here is the same as this angle here. So the first thing we should say is that by angles in the same segment, angle ABE and angle DCE are equal. Then, by the same theorem, these two angles are equal. So we can say again, by angles in the same segment, angle BAE and angle CDE are equal. Now, because there's already 2 pairs of equal angles, that should really be enough, but we could also say that this angle is equal to that angle because they are vertically opposite angles. So, because we have 2 triangles with 3 pairs of equal angles, the triangles are indeed similar, and that's it. Cool. Okay, number 16 wants us to prove algebraically that 0.136 recurring times 0.2 recurring is equal to 1 over 33. Okay, so I'll put my recurring decimals to fractions stuff down below. So what we need to do is turn each decimal into a fraction. So let's start with 0.136 recurring. So what we're going to do is we're going to say that x is equal to 0.136 recurring. So that number means 0.1363636 forever. Now the first thing we need is a number to do with x that has a purely recurring decimal. So at the moment it's not purely recurring because the 1 doesn't recur. So if we multiply by 10, we get 10x is 1.36 recurring. Now we need another number with exactly the same recurring decimal. So we need to move the decimal point 2 places to the right. So to do that, we're going to multiply both sides by 100. So we get 1000x is 136. 0.36 recurring. Now the reason for doing that is we can now lop off the decimals using subtraction. So 1000x minus 10x is 990x. And 136.36 recurring minus 1.36 recurring is 135. Divide through by the 990, we get x is 135 over 990. Now that has at least a common factor of 5. I think has a common factor of 9. In fact, has a common factor of 45. Doesn't matter though, put it in your calculator and I will do it for you. So 135 over 990 is 3 over 22. Okay, so now if we do the same, now luckily it's a lot easier for 0.2 recurring, so we call y 0.2 recurring, multiply both sides by 10, 10y is 2.2 recurring. Lop off the recurring part by subtracting. So we get 9y is 2. And then y is 2 ninths. So we now know that 0.136 recurring times 0.2 recurring is 3 over 22 times 2 ninths. So that gives us 6 over 198. Now there's a common factor there of 6, but again put it in a calculator and you will indeed get 1 over 33. Boom. Okay, number 17. So we got a sector with a triangle inside it and a shaded region. So, ONQ is a sector of a circle with center and radius 11 centimeters. So, straight away, let's get that on there. So, we know this whole length is 11 centimeters. Okay, then we're told A is the point on ON and P is the point on OQ, such that AOB is an equilateral triangle of side 7 centimetres. Okay, two important parts of information there. It's an equilateral triangle. So those three lengths are the same. Also, in an equilateral triangle, every angle is 60 degrees. Now we only need that one down there. We want to calculate the area of the shaded region as a percentage of the area of the whole sector. Give our answer correct to 1 decimal place. Okay, so lots to do here. So we need to find the area of the whole sector, the area of the triangle. From that we can then find the area of the shaded region and then get that as a percentage of the whole thing. So let's first of all do the sector. Okay, so first of all, the sector has an angle of 60 degrees. So that allows us to work out the fraction of a whole circle that the sector is. So 60 over 360 is 1/6. Now, the formula for the area of a circle, and if you haven't yet, make sure you check out my formula video down below, where you can also get a printable PDF of all the formulas that you need. So the area of a circle is pi times the radius squared. So the area of this sector is 1/6 times, the radius is 11, so the radius squared is 121, so it's 1/6 times 121 pi. Now that gives us 63.36 centimetres squared. Okay, so that's the area of the sector. Let's now do the triangle. Okay, so where you can, area of a triangle is base times height divided by 2. Problem is, we don't know the height of the triangle. We could work it out using trig or Pythagoras, but we don't need to. There is another way to work out area of a triangle. Let's go up here. So if you have a triangle where you know an angle and you know the two sides coming out of it, the area is 1/2 AB sine of that angle. So for us, we know the angle is 60. The two sides coming out are both 7. So the area of the triangle is 1/2 times 7 times 7, so 49 sine of 60. Now that will give us 21.22. Okay, so now we can work out the area of the shaded region, which is the whole sector minus the triangle. So that's 63.36 minus 21.22 now that gives us 42.14. So that's the area of the shaded region. Now, as a percentage of the sector, think of it as a fraction. So we get 42.14 over 63.36. Now that would give us 0.665. And then multiply that by 100. And we get 66.5%. Cool. Okay, number 17. So we got a sector with a triangle inside it and a shaded region. So, ONQ is a sector of a circle with centre and radius 11 centimeters. So, straight away, let's get that on there. So, we know this whole length is 11 centimeters. Okay, then we're told A is the point on ON and B is the point on OQ, such that AOB is an equilateral triangle of side 7 centimeters. Okay, two important parts of information there. It's an equilateral triangle. So those three lengths are the same. Also, in an equilateral triangle, every angle is 60 degrees. Now we only need that one down there. We want to calculate the area of the shaded region as a percentage of the area of the whole sector. Give our answer correct to 1 decimal place. Okay, so lots to do here. So we need to find the area of the whole sector, the area of the triangle. From that we can then find the area of the shaded region and then get that as a percentage of the whole thing. So let's first of all do the sector. Okay, so first of all, the sector has an angle of 60 degrees. So that allows us to work out the fraction of a whole circle that the sector is. So 60 over 360 is 1/6. Now, the formula for the area of a circle, and if you haven't yet, make sure you check out my formula video down below, where you can also get a printable PDF of all the formulas that you need. So the area of a circle is pi times the radius squared. So the area of this sector is 1/6 times, the radius is 11, so the radius squared is 121, so it's 1/6 times 121 pi. Now that gives us 63.36 centimeters squared. Okay, so that's the area of the sector. Let's now do the triangle. Okay, so where you can, area of a triangle is base times height divided by 2. Problem is, we don't know the height of the triangle. We could work it out using trig or Pythagoras, but we don't need to. There is another way to work out area of a triangle. Let's go up here. So if you have a triangle where you know an angle and you know the two sides coming out of it, the area is 1/2 AB sine of that angle. So for us, we know the angle is 60. The two sides coming out are both 7. So the area of the triangle is 1/2 times 7 times 7, so 49 sine of 60. Now that will give us 21.22. Okay, so now we can work out the area of the shaded region, which is the whole sector minus the triangle. So that's 63.36 minus 21.22 and now that gives us 42.14. So that's the area of the shaded region. Now, as a percentage of the sector, think of it as a fraction. So we get 42.14 over 63.36. Now that would give us 0.665. And then multiply that by 100. And we get 66.5%. Cool. Okay, number 18, a nice tricky indices equation. So, 16 to the power of a fifth times 2 to the power of x is equal to 8 to the 3 quarters. Work out the exact value of x. Good times. Right, to solve an equation like this, you need the base numbers to all be the same. So at the moment the bases are 16, 2 and 8. 16 and 8 can both be written as a power of 2. So 16 is 2 to the power 4. 8 is 2 to the power 3. So we can rewrite this as 2 to the power 4 to the power of a fifth times 2 to the x is equal to 2 to the power 3 to the 3 quarters. Okay, now if we simplify the indices, so when indices are on opposite sides of a bracket, they multiply together. So 2 to the power 4 to the power of a fifth is 2 to the 4 fifths. And 2 to the power 3 to the 3 quarters is 2 to the power 9 over 4. Okay, now on the left, because both bases are now 2's, we can combine the indices. So when you multiply them together, you add the indices. So on the left, we got 2 to the power x add 4/5 is equal to 2 to the power 9/4. Okay, now at this point, for this equation to be true, the indices must be equal. So that means then that x add 4/5 is equal to 9/4. Therefore then, x is 9/4 minus 4/5. Now you can work that in your calculator, or we could just say x is, so go for common denominators, which would be 20, so 45 20ths minus 16 20ths and that is gonna give us 29 20ths. Now that should be fine. We could write that as 1 and 9/20. Cool. Okay, number 19. So this looks nice. 2 minus x add 2 over x minus 3 minus x minus 6 over x add 3 can be written as a single fraction in the form ax add b over x squared minus 9, where a and b are integers, so whole numbers. Work out the value of a and the value of b. So, 4 marks. Okay. So, what we're going to do is not do everything in one go. So, let's first of all look at combining 2 minus x add 2 over x minus 3. So, we can think of 2 as being 2 over 1 as a fraction. To combine these fractions, we're going to want common denominators. So, we can turn 1 into x minus 3 by multiplying by x minus 3. So, we're going to multiply 2 by x minus 3 over x minus 3. And we get that. Now, if we've got that, then minus x add 2 over x minus 3. Again, the minus affects both terms on top, so I'm going to put brackets around it. Okay, so now that we have common denominators, we can just subtract across the top. So if we expand the brackets on the first fraction, we get 2x minus 6, and then we get minus x and minus 2. all over x minus 3. Okay, now we can simplify the top. So we have 2x minus x, so that's just 1x. And we have minus 6 minus 2, which gives us minus 8. And then that's all over x minus 3. So, we've combined these first two terms. So, we've combined that. So, what we now need to do is subtract x minus 6 over x add 3. So now we want to do x minus 8 over x minus 3 minus x minus 6 over x add 3. Okay, so the common denominator that we're going to go for is x minus 3 times x plus 3. Is anyone having fun yet? Okay, so on the first fraction we're going to multiply the top and bottom by x add 3. So we're going to have x minus 8 times x add 3 all over x minus 3 x plus 3 minus, now for the second fraction we are multiplying the top and bottom by x minus 3. So we get x minus 6 times x minus 3 all over x add 3 x minus 3. Or x minus 3 x add 3. Same thing. Okay, so now we have common denominators, we can write this all as one fraction. So now we're going to expand the tops of the fractions. So for the first one, we're doing x minus 8 times x add 3. So we are going to get x squared. We're going to get minus 8x add 3x, so that's minus 5x. Minus 8 times 3 is minus 24. Okay, now we got this subtraction in the middle. So I'm going to do the second expansion inside of some big brackets. So now we're doing x minus 6 times x minus 3. So that's going to give us x squared minus 6x minus 3x is minus 9x. Minus 6 times minus 3 is going to give us plus 18. Now, on the bottom, x plus 3 times x minus 3 is a difference of two squares. It's x squared minus 9. Okay, so up on top then we have x squared minus 5x minus 24 Now, everything inside the big square brackets are being multiplied by minus 1. So we got minus x squared minus 9x, so that's add 9x, and minus 18 all over x squared minus 9. Okay, so the x squared cancel, so we got x squared minus x squared, then we got minus 5x add 9x, so that's gonna give us 4x, and then we got minus 24 minus 18, so that's minus 34 minus 42 all over x squared minus 9. So for the answer, they wanted the values of a and b, so a is 4, b is minus 42. Cool. Okay, number 20. The diagram shows part of the graph of y equals x squared minus 2x add 3. So there's our graph, good times. Part A says, by drawing a suitable straight line, use your graph to find estimates for the solutions of x squared minus 3x minus 1 is equal to 0. Okay, so how do these two things connect? Well, what we need to do is turn x squared minus 3x minus 1 into x squared minus 2x add 3. And what that's going to give us, when we've done that, on the right, we're going to end up with the equation of a straight line. And then we're going to draw that straight line, and then where that straight line and our graph meet, those are the solutions. So, again, we want to turn x squared minus 3x minus 1 into x squared minus 2x add 3. So how are we going to do that? Well, first of all, let's add x to both sides. So we're then going to get x squared minus 2x minus 1 is equal to x. And we then need to turn the minus 1 into positive 3. So we're now going to add 4 to both sides, and that's going to give us x squared minus 2x add 3 is equal to x add 4. So the straight line that we want to plot is y is equal to x add 4. So this is kind of simultaneous equations. Where curves and lines meet are the solutions to simultaneous equations. So x had 4, well, let's plot a few points. So when x is 0, y would be 4, so there. We could say when x is, how high does our scale go? Quite high. So we could say when x is 2, y is 2 add 4, which is 6. So that's there. And do 3 just to be sure. When x is 4, y will be 8. Okay. Now, let's attempt to join those points with a straight line. Probably won't go very well, but we'll have a go. Okay, so that looks pretty good. So, again, the solutions are the x coordinates of either blue line, hence our curve. So we got this one here. Now if we go down, we can see that would be, well, it was about there. So from the scale, that's going to be about 3.4. And the other one, just there, that's going to be about, there's about there, so that would be about minus 0.35. Cool. Okay then, for part B, we're told B is the point on the graph of y equals x squared minus 2x add 3, where x is equal to 2. We want to calculate an estimate for the gradient of the graph at point P. Okay, so to estimate gradients of graphs, we use tangents. Now a tangent is a straight line that its curve at one point only. So x is 2 here, so point P is this point here. So what we need to do is try and draw a tangent and then work out the gradient of the tangent. So can this might not go too well, but we'll have a go. Okay, so in the real thing, obviously you can use a ruler and it's a lot easier. Well, it doesn't look too bad. we'll do okay, so what we now need to do is work out the gradient of this tangent. Gradient is difference in y divided by difference in x. So we now need to use two sets of coordinates. So this coordinate here, at least, will be nice. So we know the x coordinate is 2 and the y coordinate is 3. Now, ideally, we need to find another point with nice-ish coordinates. So, because it's an estimate, we'll be alright using this point. So the y coordinate, this guy would be 5. And the x coordinate, let's go 3.2. Let's just go 3. Okay, so the gradient then, m, is difference in y, so 5 minus 3 over difference in x, 3 minus 2. So that gives us 2 over 1, so that gives us 2 as our estimate. Okay, number 21, probably a bit of a nightmare. So the diagram shows 3 identical circles inside of a rectangle. Each circle touches the other 2 circles and the rectangle as shown in the diagram. So, one thing to note is that the diagram is symmetrical. The centre of the middle circle is halfway along the length of the rectangle. We're told the radius of each circle is 24 millimeters, and we want to work out the area of the rectangle, giving our answer correct to 3 significant figures. Good times. Right, okay. So, the area of a rectangle is base times height. Hopefully that's not news. Now we can work out the length of the rectangle. That's not too difficult. That's 4 lots of the radius of a circle. So we know the radius is 24 millimeters. So the length is 4 times 24 millimeters. Which is 96. Okay, so, well, that's not so bad so far. The problem is, as it stands, we don't know the height of the rectangle, and we can't find it as easily because the circles overlap. But because this diagram is symmetrical, what we can do is form a right-angled triangle using the centre of the bottom circle and one of the top circles. So, we know that length is 24. The length that we don't know and the one that we need is that guy. And the other length goes from centre of the circle to centre of the other circle. Now that line is going to go through the point where the circles meet. So this line is 2 lots of the radius, or the diameter. So, 48 millimeters. Okay, so the reason that we need this height is because we know that bit is 24 millimeters and that bit is 24 millimeters. So what we need is the length connecting the centre of the bottom circle to the top line of that right-angled triangle. Now for that then, we can use our best mate Pythagoras. So if we call this length A, Pythagoras says A squared and B squared is equal to C squared. We know C though, so A squared is C squared 48 squared minus B squared, so minus 24 squared. Now that then tells us A squared is 1728. Now that tells us A is the square root of that 41.57 millimeters. So that then tells us, or that then allows us to work out the height of the rectangle. So the height is 2 24s add 41.57. So the height is 48 add 41.57. Which is 89.57 millimeters. So the area is then 96 times 89.57 . Oh man, the phone absolutely loves to ring when I'm making these. So that will give us 8,598.7. The third significant figure is the 9, which is being told to round up. So we actually get 8,600 millimeters squared. Okay, number 22, so close to the end now. So we're given the first 5 terms of a sequence and asked to find an expression in terms of n for the nth term of the sequence. Okay, so let's have a look, see what's going on. So we got 4, 11, 22, 37 and 56. So let's find the differences between the tabs. Although, let's write them. Okay, so to get from 4 to 11, we add 7. 11 to 22, we add 11. Okay, so at this point, the differences are changing. It's a quadratic sequence. 22 to 37, we add 15. 37 to 56, we add 19. Okay, so we then need to find the second difference. So 7 to 11 is 4. 11 to 15 is 4. So our second difference is 4. Now you halve the second difference, and that tells you the quadratic part of the sequence. So half of 4, I think, is 2. So the quadratic part is 2n squared. Okay, so what we now do is write down the first few terms of 2n squared. So n squared is our square numbers, so we're just doubling our square numbers. So 2 times 1 is 2. 2 times 4 is 8. 2 times 9 is 18. 2 times 16 is 32. Now, to be honest, at that point, that's enough. So what we now do, a quadratic sequence is usually made up of a quadratic part, which we have here, and a linear part. So to get the linear part, we now subtract the quadratic part from the whole sequence. So we are now doing 4 take away 2. So that's going to give us 2. 11 take away 8 is 3. 22 take away 18 is 4. 37 take away 32 is 5. So this is indeed a linear sequence now. So it's going up in ones. So that tells us the nth term to the linear part is 1n. But it's not just 1n. If it was just n, it would be 1, 2, 3, 4, 5. But it's 2, 3, 4, 5. So n is the term number. If n is 1, we get 1. But we need it to be 2, so it's n add 1. So the nth term for the whole thing in all its glory is the quadratic part. 2n squared add the linear part. So 2n squared add n add 1. For more examples, check out my sequences playlist down below. Okay, number 23, an equation of a tangent to a circle. So, check out my playlist down below for all the separate skills you need, as well as more examples. So, naturally this one is Edexcel, so it's on steroids. So, L is the circle with equation x squared and y squared is equal to 4. hopefully you're familiar with equations of circles. This is a circle centred 0, 0 with radius 2. P, the point 3/2 root 7 over 2, is a point on L. Find an equation of the tangent to L at the point P. Okay, so why have they got sides involved? Why are they so horrible? No one knows, but no point bitching. So, first thing I would recommend is a sketch. So, as I said, our circle is centred at the point 0, 0. So, here. Now, P is somewhere in the positive part of the graph, 3/2 root 7 over 2, and the green line is the tangent. So, tangents, when they meet a radius, they are perpendicular. So, when lines are perpendicular, their gradients multiply together to -1. So the first thing to do is to find the gradient of tangent. No, it's not. It's to find the gradient of the radius. So, the reason being is that the radius is the only thing for which we know 2 points. So, I'd like to call this R, gradient of the radius. Gradient, again, is difference in y over difference in x. So that's just going to be root 7 over 2 minus 0 over 3 over 2 minus 0, and that's just root 7 over 2 over 3 over 2, and that is actually, so that's just going to give us root 7 over 3. Okay, so because a radius and a tangent are perpendicular, their gradients multiply together to -1. So now we know that root 7 over 3 times the gradient of the tangent is equal to -1. So if we multiply through by 3 and divide by root 7, gradient of the tangent is -3 over root 7. Now, in general, we don't like surds on the bottom of fractions, so we're going to rationalise that. Multiply through the top and bottom by root 7, and we get -3 root 7 over 7. So we now know the gradient of the tangent. Now the general equation of the straight line is y equals mx add c. So the tangent is of the form y is equal to -3 root 7 over 7x add c. So we now need to find the value of c. To do that, we use the set of coordinates that we know lie on the line. So that's point P, which was 3/2 root 7 over 2. So y is root 7 over 2. Now that is equal to minus 3 root 7 over 7 times 3 over 2. So that's going to give us minus 9 root 7 over 14. Add C. So, this question is ridiculous. C is root 7 over 2. Add 9 root 7 over 14. Now, if we go for common denominators, root 7 over 2 is 7 root 7 over 14. So we have 16 root 7 over 14, which is 8 root 7 over 7. So the equation of our tangent is y is minus 3 root 7 over 7 x add 8 root 7 over 7. Ridiculous question, but there it is, done. As is the paper, hope you found it useful guys, really horrible one. Don't forget, every paper is down below in that playlist. Don't forget, give us a thumbs up, get subscribed, take it easy, take care.